All right. Okay, so all we're doing is taking our unit circle values and we're going to graph them. That's what we're doing. Okay, so if you have your unit circle available to you, you might want to pull it out. If you've memorized it, awesome, even better. So sine and cosine, remember that's your y-coordinate, cosine's your x-coordinate. That will just be helpful when we're pulling values off. Okay, so let's talk about amplitude. Amplitude Okay, so it's an absolute value, so it's always positive. Maybe I should put that there. When we talk about amplitude, we talk about it in an absolute value way, like your amplitude, and you'll see it when we graph it. It doesn't really make much sense now. So sine and cosine graphs do that. It's the wave. And we're going to have some asymptotes in tan graphs. So absolute value graph, always positive, is the difference between your median and a max or a min. And this is all dealing with your range. Okay, so those are all your y values. When I talk about amplitude, I'm referring to the range. It's the height or the depth. And when I talk about your median, it's the physical middle. It's the measurement of the middle. Okay, so period is, it's not I, that's supposed to be one. One full rotation. So that's a max height to another max height, or a min height to a min height, or a median to a median to a median. You have to have 3 medians. You need 3 medians and a max to a max height, or a min to a min height. And if you have a max to a min, that's half a period. Because they're like, lady, I don't know what you're talking about. And that's okay. Because when we graph it, it's going to make more sense.
I understand what you mean by median to a median to a median of it. Because that would be your first one, second, back to third.
Exactly, yeah. All right, here we go. You guys ready? No. Okay. See, this is what happens. I wrote all this stuff down and I have to say, guys, I really do appreciate the effort that you put into the class, being here online, learning from home, doing all that stuff, only seeing me 2 days a week. You guys are handling this beautifully. So I don't know if we say it enough to you guys, but you guys have been rock stars in all of this. Okay, so we're doing the sine graph. Okay? So if I give you let's start with 0. Let's start with the positive ones. Let's not start with negative. Let's start with positive. So if I put in theta has a value of 0, so if I put in a 0 right here, what's the y value? So just think about it on your unit circle. You're at a degree measurement of 0.
0.
What's your y value?
Wait, at 0?
Yeah,
1,
0.
0.
Okay, so that's the thing, like, are you on a sine graph or are you on a cosine graph? You're on a sine graph, so we're looking at just the y values. Okay, so if I go pi over 2, if I put pi over 2 in here, what is the y value when theta is pi over 2? 1. What is it when it is pi? 0. 3 pi over 2? 1. What kind of 1? -1. right? Because you're down now. You're down on the lower half of the circle. And if I go back to 2 pi, what's my y value? 0. Okay, so you needed to know chapter 4 before we could do this. Okay, so now let's do the negative rotation. So you are at
Negative 2 pi.
negative 2 pi. Negative 1. You're at negative pi. 0. You're at negative 3 pi over 2. 1. And you are at negative pi. Negative 2 pi, sorry. 0. Okay, that's pretty exciting, eh? You guys are like, not really, but we'll go with it. Okay, so we're going to graph this. Notice I didn't put any increments on it. It's pretty lackluster of a chart. I'm going to drop halfway. I'm going to put a pi in here. I'm going to put a 2 pi here. This would be my 3 pi over 2. And this would be my pi over 2. What's my maximum height of this graph? What's my minimum height of this graph?
0.
What's my minimum height of this graph? Negative 1. What's my median of this graph?
0.
0. Good call, good call. Oh, so I guess I gotta put some let's do what? And negative 1. Alright, that's exciting, everybody. Alright, so remember that this is theta. It's usually your x-axis, but really it could be anything. And this is your y-axis here. Alright, so when theta is 0, what's y? It's also 0. When it's pi over 2, I'm at 1. When it's pi, I'm back to 0. When it's 3 pi over 2, negative 1, 2 pi, 0. Now let's go backwards. Not the reciprocal, because you can't reciprocate 0. So now I'm going to connect all my dots. Hey, you can kind of tell that that's sort of pink. Sort of, kind of. Okay, these should be smooth curves. So normally I blame it on the digital marker, but obviously you can tell I have problems just in my everyday smooth curve kind of life.
Is this the straight edge kind of person?
Straight, yeah, I am a straight edge kind of person. Okay, I don't know what's up with this math today, but every time I breathe, it's coming out the top of it, and like, I'm just crying, like, because I'm breathing into my eyeballs. Sorry, just having a moment here. Excuse me while I cry. So let's talk about this graph for a second. I want to talk about the arrows of this graph. So you guys would agree that the maximum of this graph is a positive 1. You guys would agree with that? And you would agree that the minimum is a negative 1.
In the 1.
Yeah. What's the median?
0.
0. Now, it's kind of easy to see because it's like, what's the halfway distance? So from here to here, so from your median to your maximum has a value of 1. From your median to your minimum, and you guys are like, well, that has negative 1. But remember what I said about amplitudes. Amplitudes are treated as absolute values, like they're positive. So even if you're going down, we still call it an amplitude of 1 because it's just your distance away. All right.
But if you're at 0, 0, then you don't have 1.
What?
Well, there's nothing for the median at 0, 0.
No. But median isn't a point. It's on your range. It doesn't have anything to do with the x's. So I have a maximum. My graph can't pass 1, and my graph can't go below negative 1. And if I were to cut this graph in half, it's a sinusoidal function, so it's similar to parabolas. So it's like symmetrical. It's a parabola. So if I fold it in half, this should dump up here and this should dump down here. So this, right along here, is my median. Where can you fold that graph in half? And this tip will be at the same height as that one, right? That's what your median is. If you're unsure where your median is, you can use some math to find it. So sometimes, like this one's really nice and easy, you can see it. But we're going to be doing transformations on this graph. So that's what I was saying to you, Jordan, in the email. Chapter 4, no real transformations. We're back to graphing now, so now we're going to deal with transformations. So chapter 4 is kind of like a breath, and then chapter 5 is like 1-2 punch, like it's coming back. Guys, like no thanks. Okay, another thing I want to point out is my arrows, the direction of my arrows. Now, graphs, sinusoidal graphs you're going to find. So my graph starts in a median, it starts at 0, starts there. So sine graphs always start at medians. All right, so a positive sine graph starts at a median and heads to a maximum. And once you hit a max, where are you headed then? You're headed back to 0, which is my, what's the name of it? Median. So I go median to a max, to a median. Then where am I going from the median? To the minimum. To the median again. To the median. So when we talk about periods, median, median, median. You have to have 3 of them. What's the period of this graph?
0.
So now we're talking about domain. So period is about the domain. The amplitude is about the range. 2 pi. That's where I see a median, a median, a median. You can also measure from a max to a max. Let me grab a different highlighter. So maximum I hit at negative 3 pi over 2, and I hit another maximum at pi over 2. You guys would agree with me? So let's make them both absolute values, add them together, and you get 2 pi. So it doesn't change where you measure it from, it's still 2 pi. Because here you would have traveled 3 pi over 2 plus another half of a pi, which would be 4 pi over 2, and that is 2 pi. You could go from a minimum to a minimum. Same deal, this is 2 pi. So it doesn't matter where you measure it because it's symmetrical, you're still going to get the same period of 2 pi. So if you measure it from a max to a max and you get pi, and then you measure it from a median to a median to a median and you get 2 pi, something is wrong with your graph, or your counting. So your period is your period is your period. So we've graphed 2 periods on this one.
So I'm guessing there's probably going to be a question that's like, is this a functioning sine graph, and we have to measure max to max, min.
Oh, we're going to do all kinds of stuff with this, and you're going to cry a little about it.
Yay.
Yay. Okay, all right, we're going to try to go a little bit faster on this one, not too much. But now we're dealing with the cosine graph. So cosines are my x values. So let's start at 0 again. So we're in cosine. So when theta is 0, what is the value of x? 1. Pi over 2. 0. Pi. What kind of 1? Negative 1. 3 pi over 2, so you're down here. 0. And you're back to 2 pi? Positive 1. So now we're going to go backwards. Negative pi over 2. 0. Negative pi. Negative 1. Okay? Negative 3 pi over 2. We're here. 0, and negative 2 pi? Okay, so what do you notice about this chart? Maximum, median, minimum, median, maximum. So you're going in a pattern. There's a pattern there. You may not see it. You're like, Scallion, that's a bunch of zeros and ones. Like, I can't see this. It's not that terrible. You'll get it. Like, you will get it the more we practice at it. So again, we're just going to graph this thing. And this is the only shot I have at making it somewhat equal, is to do it like this. I'm like, okay, halfway is negative pi, all the way is negative 2 pi. Do you guys have to do this, or are you guys like way better at visual things than I am?
Depends on the day.
Okay, fair. It's a Monday, so no judgment anywhere. Okay, I'm going to try to graph it in orange. This could be a fatal error. Okay, so let's start here. When we're at 0, what is our y? It's 1. Okay, not terrible. Okay, so then we go here. So where did we start? We started at a maximum. Where are we headed? Where's the only way to go from the highest point? Is down, right? Like the only way to go is down. You can't go up. So then we're going to go to a negative 1. Then we're going to go back to our median. And 2 pi, we're going to be at our maximum again. So if I do this backwards, I don't even need to look at my table of values because I know what, now I'm just showing off, sorry. I know I'm doing with ones, negative ones, and zeros, so it ends up kind of looking like a W. Okay, let's talk about our arrows for a second. If I'm at a maximum, where's the only place I can go?
Down.
Down. So if your arrow extends this way, that's incorrect. That's an incorrect shape of a graph because you're indicating that the graph can go beyond the maximum. So your graph has to come around and point down.
So it always starts at a maximum.
Ah, okay, so cos graphs, so sine graphs always start at a median, cos graphs always start at a maximum. Now there's rules and now we'll switch this, don't worry.
And graphs start at a negative.
Yeah, tan graphs are a whole different kettle of fish.
Tan graphs are sideways.
Tan graphs have asymptotes in them. What's the reciprocal of 0?
There's 0.
No.
Nothing.
When 0's on the bottom, what happens?
It's
Of a fraction. Doesn't exist.
It's impossible.
So that's our asymptote.
Oh, we have them.
They're coming. They're coming.
Like nothing, nothing.
Asymptotes, they're here.
They're here. Okay, so let us do, so these are our basic graphs, like y equals sine theta and y equals cos theta, you just graph them. They're both sinusoidal functions. The word sinusoidal just means wave. Okay, sinusoidal just means wave. It doesn't mean sine, it means sinusoidal, a wave pattern. So when I talk about sinusoidal graphs, I'm talking about either the sine graph or the cosine graph. Sinusoidal.
It's on the green paper.
Good times. So remember that a sinusoidal graph, even though it has the word sine in it, is a wave graph and could be either of these. Okay, so what is the amplitude of the sine graph?
1.
1. What's the amplitude of the cosine graph?
1.
Also 1. What is the period of the sine graph?
That's your median. No, that's a full rotation.
Full rotation.
0.
2 pi. And what about the cosine graph?
2 pi.
Also, because remember you're going max to a max. So if I start at 0 and we're talking about domains, periods are domains, so I'm going from 0 all the way to my next maximum, which occurs at 2 pi. So I've traveled 2 pi. FYI, tan is not 2 pi.
Tan is.
Tan is pi.
size, kind of.
Tan's pi.
But it's also
Oh,
kind of.
the tan is a circle.
Tan is not a circle.
Tan is a.
Tan is a
half
dot.
of it.
Tan is like,
Tan doesn't exist. Oh, yeah. Tan is like the.
it does, like, it's like a little dance.
Sideways or bigger sideways?
It goes, whoa.
Oh, wait, you mean it's.
Tan does this.
Tan is a wavy sideways.
Oh, okay. Got kind of.
And then it's got asymptotes on either side of it. Okay. Domain. Let's talk about the domain of your sine graph.
Domain is infinity.
Infinity.
Well, two times.
Okay, what do you get? Okay, so, no, in negative infinity to positive infinity. What about the cosine graph?
Same.
Same. I'm going to write it like
Working
this.
with y, so the domain will always be.
I'm going to write it as XER. Those two things mean the same thing. And really, I used theta, so this should be a theta equals X, or theta equals ER. Theta is an element of the real numbers. Or we can write X, ER. All these things mean the exact same thing. So just don't get freaked out when you see them.
The range is -1 to 1.
Yes, inclusive or exclusive?
Inclusive.
Inclusive. So I noticed this happened on the transformation test. Please make sure they're in the right order. The lower limit is always on the left-hand side. You always say how low first to how high. So don't flip those around. And what about the cosine graph?
It would be the same thing.
Exact same thing.
You're basically just copying each other until the y, that's not even y, no, the y-intercept is different.
The y-intercept is different. So let's talk about the zeros of the function. What are zeros?
Where they hit 0.
What kind of zero? Zeros are your x-intercepts.
So for the sine unit, it would be 2 pi, pi, -2 pi, and -pi.
Okay, so if we flip back to this graph, but if oh, geez Louise, sorry. So my first, where's my first,
0.
is at 0, right? Everybody agree with me?
Yeah.
And then my next one's at pi, and then my next one's at 2 pi. So I haven't given a restriction on the domain. You guys told me the domain goes from negative infinity to positive infinity, which is then a general statement for the x's.
Negative infinity pi.
We gotta do a general statement. Where's the first place we see it?
0,
0. And how far do I have to get to my next one?
pi.
And so just measure here. From pi to 2 pi, is that also a distance of pi?
Yes.
Yes. Okay, so now we're gonna do a general statement. So 0 plus, what am I adding?
Pi.
I'm adding just a pi, k, where k is an element of the integers. Does that make sense to everybody? We're making a general statement because I didn't put a restriction on the domain. So my zeros will start at 0 and they will go every pi, whether it's positive or negative, you'll have a 0 of the function.
So we find
So now let's talk about our cosine graph.
-2
So where's our first one?
pi over 2.
Pi over 2.
And it goes up pi again.
It goes up pi again. So this one's going to start at pi over 2 plus
Pi k.
pi k, where k is an element of the integers. Oh, goodness gracious. Okay, y-intercepts. FYI, you only have one for each graph.
0 for sine
0 for sine.
and 1 for the cos.
Asymptotes? Any asymptotes on this?
1 and -1.
Ooh, you're thinking horizontal asymptotes. I was thinking vertical asymptotes. It follows sinusoidal behavior, so there's not really an asymptote there. The max and min is blocking that, but I don't think you're wrong, Cam. Like, I think your idea of those horizontal asymptotes is a really unique one. Okay, so that's that. That's exciting.
Yeah, that really good. That is, no, it was nice.
This is so much easier than I thought wavy things would be. Like, I looked at grade 12 stuff in like grade 10, and I was like, oh, you get waves, but
It's not terrible, but it is terrible. People don't like this unit. All right, guys.
Like the last one.
Okay, we're going to do transformations. We're going to do transformations. You guys remember this? Y equals AF B X minus C plus H. Do you guys remember that?
Yep.
What, if there was a number there,
One.
well, it's always the invisible one. What if I changed it to a 2?
Then
Then what do we do? Mathematically, tell me what we do.
You have to stretch the graph.
harmonica.
We don't have to play the harmonica.
That's
Okay, you guys are here.
That's a-
You guys are playing with a B,
That's the
doing the harmonic.
harmonic.
Isn't that an accordion?
Or,
Yeah,
yeah,
that would be-
harmonica goes.
I was like, isn't that? I'm like, I feel like this is the accordion. Okay, but that's the B. B is the accordion.
Stretch or compression.
This is like the stretching of the cheese, right? Like, no? No? Nobody else does this? When you, no, okay, never mind. All right, so when we're dealing with this, the 3 is in front, the half is in front, the -2 is in front. All right, so we have, these are vertical stretches, right? So the A talks about a vertical stretch, the B talks about that horizontal stretch. Okay, so let's do, what am I doing? I'm doing a sine graph. So sine x. So I'm just going to do this real quick. So sine at 0 is 0. Pi over 2 is 1, 0, -1, 0. You guys are going to get really good at these. These are just your axes. Does everybody feel confident with them? Like your unit circle, your axes, everybody feels pretty confident with it. So if I drop on the 3 sine here, what am I doing to the y values? Right, like this mapping rule would be x, y, and it would go to x, 3y, right? Everybody agrees with me?
0, 0 would stay the same.
0, 0, so this would be an invariant point, right? Because it didn't change.
Pi over.
Oh, hang on, guys. We need to put some. Let's do pi over 2. Let's do pi. And this would be 3 pi over 2. I'm having a hard time with this. 1, 2, 3. 1, 2, 3, 4. This would be 2 pi. All right, and we're going to go 1, 2, 3. -1, -2, -3. Whew, that took me way longer to do than I had hoped. If you have 3 different colors, this would be handy to use colors on this. If you don't, that's okay too. So let's get this one down, and hopefully we'll finish this. So at pi over 2, I'm going to be at 3. At pi, I'm going to be back to 0. At 3 pi over 2, I'm going to be
-3.
-3.
And then 2 pi is back to 0.
Okay, so let's,
Perfect.
yeah, I'm going to try my best. I make no promises.
Do they look like parabolas or are they just round?
They should be more parabola-ish, but as you can see, I struggle with that.
You can stay 0 at the back.
Fighting with my pens. 0, 0. You guys are like, what are you doing, lady? I'm just dropping the original function on this, just so you can kind of see just the change in it. All right, off to my pink pen now. 0.5. 0.5.
That would be a compression.
So now we're getting shorter. So 0, 0 still stays the same. That dot's just getting bigger for me as I just draw more colors on it. This one's going to be at 0.5. 0, -0.5. and 0. So remember that you're always going back to your original sine graph, right? Like all these transformations are being done from this original. Like I wouldn't go from 3 sine down to half sine. You've got to go back to the original. All transformations are done off this original graph. Okay, now we're getting fancy, folks. Oh, I didn't label my pink one. I'm running out of room. I'll label it over here. Y equals 1/2 sine x. Okay, the last one, -2. 0, 0 still doesn't change, so my dot's just going to get bigger. So now I'm taking my amplitude of 1 and I'm timesing it by?
-2.
So when there's a negative in front, what did that tell us to do in?
It means to basically reciprocate your graph.
Not reciprocate.
Flip it.
Flip it. There'll be a reflection where? If I'm timesing my y's.
Y. Reflection in the x-axis.
Right. So this is a reflection in x-axis. Now really, mathematically, all it means, so that's the words to describe what's happening. This is the math to describe what's happening. So reflection, the negative, you got that from chapter 1. It's going to be a reflection in the x-axis. So these are the words, this is the math. So again, this dot's just getting bigger for me. Positive 1 now becomes -2. 0 just goes back to 0. -1 now becomes a positive 2. And then, so this one is my y equals -2 sine x. So what happens to the graph when there's a negative in front of it? Flips it, just like it did in chapter 1. That shouldn't be a shock. What's the amplitude on the blue graph?
3.
Okay, what's the amplitude of the blue graph? This is my blue graph right here. Okay, how about we start here? What's my median of my blue graph?
0. No.
What's my median of my blue graph?
0.
0. So what's my amplitude? Remember, the amplitude is the distance between the median and a maximum, or the median and the minimum. Okay, it's 3. What's the amplitude on my green graph? Green, sorry, is this one. Green. 2. Not -2, it's 2. The negative flipped it, but the amplitude is 2. So what are you noticing about these equations? The vertical stretch is what? Is also on a sinusoidal graph called?
It's also the thingamajigger that's always absolute value.
Okay, so the amplitude equals, so what we knew from chapter 1, we're giving it a new name because it's on a sinusoidal graph. Does that make sense to everybody? Okay, so if you need to know how to calculate your amplitude, if it's not obvious to you, you don't have to find the median, but you can just take your maximum. So my maximum was 3, positive 3. My minimum, so I'm subtracting my minimum. My minimum is -3 and divide by 2. So I'm going to have 6 divided by 2 equals 3. So my amplitude is 3. I can also find it just by looking at the equation given. Just sometimes you get the graphs and not the equations. So I think I'm going to stop here for today.